After we've identified our hypotheses and we've set up our hypothesis test, next we're going to want to calculate our p-value and our test statistic. These are the values that help us make a decision about whether we reject or do not reject our null hypothesis. The p-value specifically is the probability that we randomly select a sample with a sample statistic equal to or more extreme than the one that we collected, assuming that the null statement is true. So how likely is it that we end up where our sample was or more extreme, assuming that the statement about the population that we were given is true? Because we are calculating probability, and we know how to do that for the normal distribution and the t-distribution, we can calculate these probabilities using the CDF function on our calculator. So reminders from back in like week 3, we learned about second vars, and second vars takes us to our distribution menu on our calculator, and you can see CDF normal. So if I'm testing claims about a mean and I know the population standard deviation, I'm going to use normal CDF. If I'm testing claims about a proportion, I'm going to use normal CDF. If I'm testing claims about a mean and I do not know my population standard deviation, I'm going to want to use t-CDF because I'm using the student t-distribution. We are not going to cover this in our videos just because it's not a common procedure to do this anymore, because we live in 2025 and our calculator can do all of that type of calculation in the background for us. If we wanted to go this route where we calculated the area in the tail, we calculated our p-value using these CDF function calls, I would have to calculate my test statistic first. And that, for some of our tests, is going to be ugly. That formula starts to get ugly the more complicated the process is. So we can bypass all of that by going straight to the test menu under the stats command on our calculator. So if I press stats and go over to tests, you can see there's a whole lot of tests in that test menu. We've seen this menu last week, as I can see those interval commands, but before the interval commands are the test commands. There are 6, depending on whether it's a mean or a proportion, whether it's 1 mean or 2 means, 1 proportion, 2 proportions, and then whether we know sigma or don't know sigma. So if it's a test for a mean and we know the standard deviation, that's a z-test. Z is standard normal. That's a standard normal function call. If it's a test for a single mean and I don't know sigma, that's the student t-distribution, so that's a t-test. If I'm doing a test for a single proportion, that's a 1-prop z-test. You will notice options 3, option 4, option 6 look very similar, but now they say 2samp, 2stamp, 2prop, because those are the function calls we use when we're comparing 2 means or comparing 2 proportions. So if it's 2 means and our sigmas are known, it's 2-sample z-test. And if sigma is unknown, it's 2-sample t-test. If it's proportions, we're doing a 2-prop z-test. And I'm going to go ahead and pull up our very first command, z-test, so we get a feel for what it looks like. You'll notice the options at the top are very similar to last week's confidence intervals. Some questions will have raw data. Some questions will have summary stats. Summary stats are more common. And it's going to ask you for the value from the problem, the claimed value. It's going to ask you for the population standard deviation. And then it's going to ask you about some sample information. This last option here is asking what the alternative statement looks like. Is it a not equal to, a less than, or a greater than? The color is irrelevant. That has to do with the draw function. You have two choices. You can select calculate, and it will just spit out a bunch of values, or you can select draw. I'm going to do both so you can see what it looks like. If I press calculate, it gives me my test statistic. It gives me the population proportion. It gives me the mean and sample. So I see my test statistic was 0. My p-value is that rounds to 0.5, which is big. And then my sample mean and my sample size, which I fed the calculator. If I go back to z-test and I run it again with that same data, and I go to draw instead, it's going to draw and shade the distribution for me. And it shows me where my test statistic sits. My sample is sitting right here at 0, and it spits out that p-value of about 0.5. You'll notice it's shaded to the right, because if I go back to that z-test function call, our alternative was a greater than. It shades in the direction of that arrow. If it is a two-tail test, it will shade in both directions. Which in our case, since one side was half the curve, now it's both sides of the curve. The reason that's helpful is it is considered good practice to draw the labeled distribution and shade in the p-value to demonstrate that you understand what that looks like in terms of our sampling distribution. We are building a sampling distribution around the sample we collected to test the likelihood of a random sample of that size falling where we did or further. Okay, in the next couple of videos, we're going to get some practice using these with some examples. If you have any questions on what you've seen so far, feel free to send me an email or drop by office hours. Otherwise, I will see you in our next video.